Hi, my name's Eric with BobCAD. I am the demo technician with BobCAD, so I normally do the demonstrations of the software program. I also do tech support, where we help customers, help them with any questions, concerns in the software program, how to help with designing a part like this. And I also do training, so including the webinars like we have today. I also do training where we offer online training, an hour or a 2-hour session, and where you can send us a part file like this here, and we can go through designing it with you if you need to, and also programming it. So here today, we're doing the webinar. It's a special webinar Thursday today, so I appreciate you guys uh, joining us live today. We normally have them every other Wednesday, but with Vimeo, we've had some technical difficulties, so I appreciate you guys tuning in today. Let me minimize that. All right. Cool. Okay, so yeah, so our Thursday webinar is going to be on multi-axis today. And so we'll get started here. We're going to be doing multi-axis. We did 3-axis roughing with this part file. And then we did a couple multi-axis features like swarf machining and morph between two curves to follow along the bottom areas in between the teeth of the bevel gear. And we actually designed this in BobCAD, and so we'll take a look at that right now before we get into the CAM side of it, just to see how easy it is to make in the CAM side, in the CAD side of it. So here with our wireframe, we created these flat areas to do an extrude boss for the flat areas, and then for the bevel gear area along the sides here, we went to the wireframe over here, and I'll actually rotate it around a little bit. You can see right here in this area, I created that wireframe on a different UCS on the front plane, on the front UCS, user coordinate system. And we went to create 3D, went to revolve surface and revolve that area around. Then the only thing left was the teeth of the gear, where we created the wireframe along the side here of the part by creating a UCS on that angled surface there. Take a look at the part file again to see that a little bit better. So right on the side there, we sketched the 2 arcs and the 2 lines for the teeth of the gear. We didn't really have like a technical drawing to make off of it, so we just sort of sketched a couple arcs, and you can go in and create the specific radius that you need from endpoint to endpoint here. And then we went to did an extrude boss with a specific angle going down to the bottom of the solid, and then we made copies of that extrude boss all the way around from there. So if you guys have any parts like this, and you've done this kind of multi-axis machining, let me know in the comments section. If you have any questions with any multi-axis stuff that you're working on, let me know, and I'm more than happy to answer those questions in the webinar. Those are sort of like the most important things that we try to get out of the webinars here, is seeing exactly what you guys are programming. So we've got the part file, we made the 3D model, we're going to get into programming, and we're going to do that by going into the CAM portion of it, go to the top and go to CAM, go to a new job, and we'll be going to milling. And we have some multi-axis milling machines in here by default. You can see like the Haas machines. We have a 4-axis for A or for B. So that would be an A-axis rotation or a B-axis rotation as well. And then we also have in BC, which stands for BobCAD, here in our BobCAD system, we have our 3-axis milling machine. We have our 4-axis milling machine. And all of these BobCAD milling machines are pre-programmed. The post-processor formats the G-code for a FNUC-based G-code here. And we have some 5-axis machines here as well. We're using the table machine. That would be, you can see in our simulation when we get into it, you'll see the platter and the trunnion rotate for the 2 axes. We also have head. That would be if the spindle's able to rotate in an A and a B axis. We also have head table. If one of the rotations is for the spindle, one of the rotations is for the table. Cool. So we're going to BC table. We go to stock wizard, where we can click on the workpiece so that we can view that in our simulation. We go to our stock, where it was something like this cylindrical stock, but let's say we've already turned this area. So all we have to focus on is the teeth of the gear. I just went to wireframe, went to wireframe here under stock definition, which is the next one over. Selected my wireframe here and hit calculate stock. Now you can see it's trying to extrude in the Z direction, so I want to extrude it in the Y axis. So you can see the wireframe is actually just extruding flat across. I want it to revolve around. So that's the last option here, which is revolve. Select that wireframe again and hit calculate. Now it's trying to go around the X axis. In this instance, I need it to go around the Z axis. And hit calculate. There we go. So that's our original stock that we're starting with in this milling job that I created. We had extrude cut the center out as well. We're just focusing on the teeth of the gear. And so to machine the rest of this stock out, we started by going to machine setup 1, which is on top of the part here. I right click, go to mill 3 axis, and we're doing an advanced rough operation from our machining strategy page. Next page, we have our posting. Work offset number is 1, which is G54. Multi-axis post you'll find in the multi-axis machines. We always recommend not changing anything in this page because everything is going to be set up for your specific machine build. If there needs to be any changes in here, we can do that for you. And then we get to the next page, UI choice, which stands for user interface. So this is going to be in our 3-axis Pro and further. We have a standard user interface, which we set up our tool. We set up the cut pattern for an adaptive roughing operation, depth of cut, step over, those kinds of settings. So that's that standard user interface that you're used to. Under the advanced rough, we also offer the advanced user interface. So when you open up this advanced user interface parameters page here, you can see your feed rate that you can set. So your feeds and speeds on the first page. Your next page is your geometry selection. So we're doing the selecting the machining surfaces here. We can select a boundary here under 2D containment. What I really like here in the advanced user interface on this page is setting up our step over. We can also set up our step over based on our specific cusp height. So we can type in the cusp height here and it will calculate the step over accordingly. Makes things very easy for us. We can also set up an adaptive step over for the cut pattern, just like in the standard UI. We're doing 3-axis on the next page here, tool axis control. We're doing 3-axis roughing. We have a gauge check page, our linking for each step over, and all those options just as before in the standard UI. And so after the advanced UI, really all that's left is setting up the tool and setting up the last page's MDI for the manual data input that we may want to order. We may want to type in any G code before or after the operation manually here. And so you can see the advanced rough does a great job of just removing the remaining stock, getting down to our workpiece here. And then our next operation is going to be focusing on the bottom flat areas here. So take a look at that here. So you can see, and we'll actually backplot it first, and then we'll take a look at how we created the toolpath. So it's going to start I can right-click on Morph Between Two Curves under this feature. And under any operation like this, I can go to Backplot so that I can see the tool location where it's starting at. And you can see the 5-axis rotation already, sort of like with the tool rotated like that. Now the spindle's not going to rotate with this BC table machine. The trunnion's actually going to rotate. We'll see that a little bit more in the simulation. But you can see it as we rotate it around. You can see it play through and see the current tool location as it moves across the flat areas on the base of the gear. And so we created this toolpath by right-clicking on Machine Setup 1 and going to Mill Multi-Axis. The first one we did here was our surface-based toolpaths. We can see everything. Let's take a look at the 5-axis Mill Pro versus the Premium that we offer now. So the Mill 5-axis Pro will offer wireframe, where the tool will follow along any wireframe you select. And these black lines would be sync lines, where the tool is going to sync up at a certain rotary angle to follow along the wireframe toolpath. We offer multi-axis machining, where we can do 4 or 5-axis roughing along a part. Swarf machining, which is what we'll get into after this operation, where the tool can follow along the sides, the side walls along the teeth of the gear. Next would be deburring in the 5-axis Pro, where you could use a ball end mill or a chamfer tool to do a deburring operation along all of the sharp edges of a part. And our surface-based toolpaths. And the surface-based toolpaths, we can go through them. Parallel cuts, where you can go across or down any surfaces that you select in multi-axis. Cuts along curve, where you can have the tool go across the surface like this, and here in orange would be your lead curve that you're selecting. The toolpath will go perpendicular to the lead curve that you select. This could be in 4 or 5 axis as well. Morph between two curves, which is what we did here. We'll get into that a little bit more, but basically I selected one of the edges down at the bottom base of the gear, one edge from one tooth of the gear, and then over to the opposite side, and then the surface down on the bottom. To create a toolpath, you can see the toolpath morphs between from the start point to the end point here. So you can see like this hourglass shape. It creates the first pass right here, right along the side, and then morphs the toolpath with a step over until it gets to the last pass here. Next is parallel to multiple curves. You can select a bunch of surface edges like this or wireframe, and then it will create an array of the toolpath outward. Project curves is just like the 3-axis Pro project curves, but this is in 4 or 5 axis where the tool will stay normal to the surface. So you've got some 2D wireframe here in orange. It will project that geometry onto the surface to engrave that and keep the tool normal to the surface here. And morph between two surfaces. So you could select two surfaces if there's any gouging. You can make sure there's no gouging along the side walls here. Parallel to surface is just like parallel to curves, but you're selecting surfaces to create an array of the toolpath outward. And flow line. The morph between two curves and the flow line here, they both support undercutting. So with this shape, this surface here, you could select, and you can use a ball end mill, for example, to do an undercut with this. So we're doing morph between two curves. Next page, we have our work offset number. Next page, we have our multi-axis posting page. Next page, we have our tool page where you can go to your tool crib and select your specific tool you're using. Set your feeds and speeds here. And then your next page is your parameters. And again, here you've got your maximum step over down at the bottom right, and you can type in your cusp height based on the geometry of the tool and based on the stock you're removing. So if you type in here, let's say you want your cusp height or your scallop height to be no more than 1 thou. You can type that in and you can see the specific step over calculates accordingly. So it's only doing 31 thou as a step over across the surfaces if you set it up this way. But that cusp height option is a great way to be able to just type in your specific tolerance levels you need. That way you don't have to go into simulation, make sure everything's cut to size. You don't have to do that sort of guesswork. You can just type in the cusp height here. So next page, you have tool axis control. We're going to do 5-axis. Next page, gouge check. Next page is linking. Next page is roughing. I normally show this depth cut option. So you can click on depth cuts. You can type in how many roughing passes you want to do and how far they're going to be spaced out, and how many finish passes here and how far they're going to be spaced out. It's a great way if you want to just create some roughing toolpath very quickly. You can do that very easily here. I like the adaptive roughing option. I think it's a much quicker toolpath than this, but if you want to just create a roughing operation very quickly, you can do that here. Now we get back to our first page with surface paths, where I can select my geometry. So my first edge would be, if I hide the solid here, and where's that? Under the CAD layer. Try to find which layer there we go. So on this last layer here, you can see the edge curves that I selected. So here's our first edge curves on this side where my cursor is, and then the second edge curves would be on the opposite side right here. Then the surface would just be this drive surface right here. It's easy as that to create the toolpath for your multi-axis milling operations. These are surface-based toolpaths, so the toolpath will be driven from the surface that you select. And then we can take a look at the toolpath here. It just creates the toolpath for this one area to begin with. And then as I turn on the solid here, you can see I created the rest of the toolpath right here by doing a toolpath pattern. And I can create that by right-clicking on a feature. I go to Add Toolpath Pattern about halfway down here. I go to Rotate. And let's see what I have in my toolpath pattern. I can't remember how many teeth for the gear I did. But how I got this angle was very easily figuring out I've got 32 teeth for the gear. I type in 360 divide by 32 teeth, and it gives me the angle that I need, 11.25 degrees, rotating that around, and I'm making 31 additional copies from my original toolpath. And once I click OK, it creates that toolpath for me right there. And then my original one is from my morph between two curves. So that's how I created the toolpath for all 32 areas there. And then after these two, I'll turn off the swarf machining for now. And we'll take a look at simulation just without the finishing on the sidewalls that we haven't looked at yet. So we're just looking at the roughing, and we're looking at the morph between two curves that I created thus far. If I go to the top, I click on Start Simulation. And if you guys have any questions with the advanced rough or the morph between two curves so far, let me know. You can see this is our BC table machine. And if I rotate it around like this a little bit, once it loads in, we'll see the platter and we'll see the trunnion as it moves around. And then we'll slow it down a little bit. We'll hit run. And we'll speed it up a little bit now. There we go. So here you can see the roughing so far. As it just sort of follows along like that. Gives us our estimated cycle time up at the top. Says it will take 1 hour and 28 minutes for the roughing that we're doing here and the morph between two curves that we've created so far. If I want to pause it, I can always click on next op to skip the rest of the roughing here. And then we get to the tool where it's going to be rotating. Now the spindle's not rotating like this. If I look at the machine simulation, you can see the trunnion and the platter rotate here as it cuts inside of that area there. Oops. Rotate a little bit more there. There we go. What I really like in the new simulation is I can move this to a second monitor so that I can, you can see that I can sort of multitask this way. I've got my simulation running over here. I can change the toolpath if I need to, recompute it, and then I just hit restart here in the simulation to be able to just update everything and be able to see everything updated from there. Let's actually see the rotation there. That's a little, that would give me a headache. Okay, there we go. So we'll run through it, see it a little bit better this way without the machine build in there. And then once everything's finished up, I can go over here to my analysis tab. Down at the bottom right corner, you can see in simulation. And under the drop down in the analysis tab, we have a bunch of different options to see different colors on the stock. None would be just leaving it blue here to see. The next option down is tool number. It'll show me based on the different colors here what tool number is machining what. So here in green is the 1/4-inch ball end mill that we used for the morph between two curves. The 1/2-inch flat end mill that we use for the roughing, there's nothing that's been machined with that. I mean, we've already seen the roughing, but everything that we're finishing up is with green here with the finish pass. Operation number, all multicolored things here to show us these are all different operations technically with the toolpath pattern. What I like in here is you're able to see what's being machined from what tool and from what operation. You can double click on each color to see to change the colors here as well. I want to see all these different multicolored options there. You can always change them. Then our next one is the one that I really like using. So I click on deviation and I hit refresh. It'll show me different colors here on the stock depending on how much material is remaining till we get to our workpiece that we've defined. So you can see here in green, everything is cut to size with a cut tolerance of plus or minus 8 thousandths. And I can see in the teal color here, anywhere between 8 and 26 thou remaining in the corners here. So I'm going to use the swarf machining along the side walls to finish that up with a smaller tool to get into the corners a little better too. And then you can see these dark blue colors. Anything dark blue is 64 thou or more remaining. We didn't focus on drilling the holes or this area here. We're just focusing on the teeth of the gear here today. And if everything looks good, if everything's cut to size, we can close out of simulation. Next to simulation, we can hit post. And it will generate the G-code over here on the right-hand side. We'll take a look at the G-code for a second before we get into the swarf machining here. All right, so here we have our 3-axis milling operation first. What I tend to do to find the next operation very easily in my posting window in the G-code, I can hit Control F to find, and I'm normally just trying to find the next time it outputs a parentheses. So after the first comments here for the first tool, it's going to output next cut, next tool here. And there we go. Expand this a little bit more. And you can see right here, you've got the X, Y, Z move, and then you've got your C axis rotation of 80 degrees. And then a little bit further down, you've got a C axis rotation of 80 degrees. And where did that? Oh, right above it. C axis of 80.231 degrees. And then the next output is the A axis rotation of 31.855 degrees. So there's your two axes of rotation for the platter for the C axis, and then the trunnion with the A axis rotation there. Cool. If you guys have any questions, please let me know. I'm looking at the other screen to see if you guys have any questions, comments, concerns so far with the 5-axis toolpath. I know getting started with 4 or 5-axis in BobCAD, there's going to be a little bit of a learning curve to it, but if you guys if you guys have any questions, I'm more than happy to answer them. So we're getting into the swarf machining next. And I sort of left off with the 5-axis Pro. Just to show you guys, we offer 5-axis Premium now. These are some new options that we offer. Multi-blade for impellers like this, where the tool will just sort of fit inside all of those areas to rough it out and finish all together. We offer port machining as well. So porting for like an engine block or something like that. And then we also offer turn milling, which would be more 4-axis stuff, where sort of like when if you're turning down the stock with a lathe, it'd be like that, but with a milling tool here to rough things out pretty quickly. But these are our 5-axis premium tool paths, which would be an additional upgrade. And in a different webinar that we could go over if you guys are interested in looking at the porting and multi-blade options there. But we're looking at swarf machining today. I'm selecting swarf machining, going to my next page, going to the work offset number, which is going to be G54. Next page is going to be my multi-axis posting page. Again, we don't really change anything in here necessarily. I don't even change anything in here. I let the post-processor department make any changes that may be necessary for this for any different rotation options there for your machine. Then we select our tool. We're going to be using an 1/8 inch flat end mill for these two operations for swarf machining along both sides. Then really all I'm doing on the next page is selecting my geometry selection here, which is going to be my swarf surfaces. So I click on this button here with the 3 dots. I click on, let's see, do I have it set up on this one? It should be right over here along the part, if I have it. Let's see, there it is. It's hard to see because it's highlighted in green here, but it is right there. So that's the surface that I select, that I'm machining from. And what else is there? Really, I just leave it on auto detect for it to detect which side it is going to be machining if I'm going to be doing climb machining here. We've got a cut tolerance. We've got extensions, so I'm going 1/2 inch past the swarf surface that I've selected on each side. Next page is tool axis control, which is going to be 5-axis. Next page is our gouge check page, linking over. If I want to do multi-cuts down the surface, I can set a depth of cut on the multi-cuts page. And then something that I ran into recently with another part file is we offer an option to loop around corners. Maybe if I'm going around the teeth, I can sort of loop around like that, or roll around the corners. All right, so then our last page is MDI. And we finish out that. We can take a look at the toolpath here. And we'll backplot it. So I right-click on Swarf Machining, go to backplot, and I can see the tool come down. And I can just step through and see the tool come down here. There's our 1/2" extension as it comes into the tooth of the gear. And then the 1/2" extension from here out and then retract up. So that's the toolpath I created by just selecting that surface as my swarf surface there. And then, just like I did with the previous toolpath pattern for my morph between two curves, I'm going to do the same thing here, where I go to right-click on feature and go to add toolpath pattern, rotate, and type in the angle and how many copies. And the rotation axis is going to be x0, y0, because that's where my part is located here. So I've got my first swarf machining toolpath right here. And then my toolpath pattern was 11¼ degrees again, 31 additional copies. And it creates all the rest of the toolpath going all the way around from there. You can sort of see the toolpath in green here. If I blink out the stock, we'll see it a little bit better. There we go. You can see it going along here. And then you have the same option for the swarf machining. With that operation, the only difference with that operation would be selecting the swarf surface along the opposite side of the part there. Let's see, and that was right here. So you can see my swarf surface right here. And I can even find it under swarf machining, under geometry. I can select machining surface, which is that one, opposite from the swarf machining geometry on this one. Let's see. There it is. All right, cool. So after I've selected that surface, all I really have to do is compute the toolpath. Really, all I had to do was right-click on the feature, copy it, and then I can right-click on Machine Setup 1 and paste. That way it has all of the same settings as my previous swarf machining operation, and then I can just copy and paste and then just select my new geometry as that new surface on the opposite side here. Right there. And then, yeah, that's about it for the swarf machining option. Let me know if you guys have any questions with swarf machining. I know it can be a little bit tricky sometimes with selecting the geometry and any parameters in there, like multi-cuts and things like that. Some customers try to go a little bit too technical with selecting floor surfaces, tilt lines, all those options. As long as you've got a 3D model, you don't have to worry about any of that geometry selection. You just have to select the surface that you're machining, and the software will calculate how the tool needs to tilt to follow along that swarf surface. And we'll take a look at our simulation to see how that looks. Alrighty, so I'll hit run. We'll see the roughing here. take a look at our machine as it rotates the trunnion in the 5-axis work here. I can turn off the machine housing to see the trunnion and the platter a little bit better there. And with the machine here, with the 5-axis machines, the machine build, these are all STL files. The platter's an STL file, the trunnion's an STL file, the spindle here, I think this is made up of a couple components that are all STL files. So if you have all of this geometry, you can import it into BobCAD to be able to define this as your specific machine that you're using here. And I'll slow it down a little bit so we can see it actually play out a little bit more than just that jerking motion there. There we go. So this is the morph between two curves as it's following along the bottom in between the two teeth of the gear. And if I hit pause, I can go to next op and skip all of these morph between two curves. You can see the platter rotating around every time I go to the next step there. There we go. It's a little bit more realistic there. So these are the last two, and then it will change tools with the 1/8" flat end mill to follow along the side walls for your swarf machining. Now the simulation with the full machine simulation here is only going to be in if you go into 4 or 5-axis milling. If you don't have it on your license, it's going to be under the Machine Simulation Pro. So if you only have 3-axis milling, you could always just purchase the upgrade of Machine Simulation Pro to be able to see your specific machine in here. But if you go into mill 4-axis Pro or mill 5-axis Pro territory on your license there, it will automatically have the Machine Simulation Pro on your license. Now, one last thing as I close out of simulation and finishing up for today, I get a lot of customers. This is one of the most common questions that I get when customers are looking at the simulation like this. Sometimes they'll open up their simulation and they will see their stock down in the table of their machine. And we'll take a look at how that looks here. Is it going to show? Yeah, so you can see the stock is inside of the table. I'm trying to run the simulation, and all it's showing is, well, the tool's going down into the table here. You don't want to see that necessarily. That's not going to be very helpful. And so we get a lot of tech support customers, a lot of tech support calls from customers when people get started with multi-axis like this. So if you don't want to see the stock down into the table and the tool hitting the table here, you can close out a simulation and you can raise the stock above the table by going into your machine setup, right click on machine setup 1 and go to edit. And on your machine setup page, down at the very bottom, you'll see these entries for work offset XYZ. X, Y, and Z. So in the Z axis, I'm raising the work offset XYZ by the thickness of the stock. This part is 6 inches tall, so I'm going to type in 6 and click OK. Now what I've done was I've raised the machine setup, which I've raised the machine setup in simulation from the top of the table to 6 inches above the table. That's where it initially starts at in your simulation. Your machine setup initially starts at the top of the table. So all I've done is raise the machine setup in simulation up 6 inches. It does not change anything in the G code. It only changes the simulation. I get a lot of customers that ask that as well. So it does not change anything in the G code at all. It only changes the machine simulation in the simulation up 6 inches here. So that way, you've got your stock on top of the platter here for your machine. And that's how it can simulate correctly. Just leave you guys off with some more information with learning how to set up things correctly for your simulation when you're getting into multi-axis machining here. So I think that's a good start with some of the basics in multi-axis machining. We went through basic 3-axis advanced rough to rough things out here. And then we got into morph between two curves, which is one of the most frequent ones that I use in multi-axis machining to follow along any geometry, to have the toolpath be driven from the surfaces that you've selected in that operation. And then you have your swarf machining for a tool to follow along the sidewalls of the tooth of the gear here. I want to thank you guys for viewing the webinar today on Thursday. Normally we have our webinars every other Wednesday. We had some, things, I'm going to blame Vimeo on this, from yesterday with trying to get this broadcasted. But yeah, we had the webinar today, August 21st. So the next one is going to be September 3rd. And the topic is to be determined. We always send you guys an email with a survey to find out what specific topic you guys would like to see so that these webinars are tailored to your preference. So I want to thank everybody for viewing the live event today. And we're sort of finish off with simulating the 5-axis stuff here. And so I want to thank everybody for viewing the live event today here on multi-axis machining. I'll hang back for a few seconds just to see if anybody has any questions for what I've gone over today. And yeah, I don't see anybody asking any questions here. So it looks good. All right, hope to see you in the next webinar, September 3rd. And thank you again for everyone viewing this event live. It's recorded, so you can go back and view it as many times as you need to. And call us if you have any questions. All right, thank you very much. Have a great day.